Hi students, welcome to Vidhu Academy. So today we are going to discuss DPP 5. Okay, so physics questions from DPP 5, which is from the chapter magnetic properties. Okay, so so the chapter name is magnetism, right? Magnetism and matter. So 16, the first question in the physics section. Okay, so the first question here is a bar magnet of moment m vector is equal to I cap plus j cap is placed in a magnetic field induction b vector is equal to 3I plus 4j plus 4k. The torque acting on the magnet is. Okay. So here the magnetic moment is given. Okay. So magnetic moment. Okay. So the magnetic moment so magnetic moment vector is given. Okay, so magnetic moment vector is given as I plus j. Okay, so I plus j. Then magnetic field vector is given. Okay, so magnetic field how much is given? So magnetic field is given as 3I plus 4j plus 4k. 3I plus 4j plus 4k. Okay, so now they are asking what is the torque. So torque vector is equal to m vector cross b vector. Okay, m vector cross b vector. So this will be equal to, okay, determinant of I j, okay, I j k. Then here we will get what is the coefficient for m vector? 1 1 0, and then here we have 3 4 4. Okay, okay, so 3 4 4. Okay, so now this will be equal to, okay, so this will be equal to, so 4 minus 0 I, okay, plus, sorry, minus, okay, minus 4 minus 0 j, okay, plus k cap ke enna varum 4 minus 3 k cap. Okay, so this will be equal to 4I, okay, minus 4j plus k. Okay, so this is the answer. Okay, 4I minus 4j plus k. So option A. Okay, 4I minus 4j plus k. Option A is the correct answer for this question. Okay, next 17. There are 4 lightweight rod samples A, B, C, D separately suspended by threads. A bar magnet is slowly brought near each sample and the following observation noted. A is feebly repelled. A is feebly repelled. Now the A is diamagnetic. Okay, A is feebly repelled. Now the A is diamagnetic. Okay, so A வந்து diamagnetic. Okay, wow. அப்புறம் வந்து is given that B is feebly attracted. B is feebly attracted means B should be paramagnetic. Okay, okay, so next C is strongly attracted. அப்பனா வந்து C வந்து ferromagnetic. Okay, C வந்து ferromagnetic. Okay, D remains unaffected. D remains unaffected. Upon the D should be non-magnetic. Okay. So the answer for this question, B is a paramagnetic material. Okay. B is paramagnetic material. Option A. Okay, wow. Option A. Okay. So next 18 question. Okay, a bar magnet is cut into two equal halves by a plane parallel to the magnetic axis. Okay, the following physical quantities, the one which remains unchanged. Okay, so they are saying that there is a magnet. Okay, there is a magnet. Now this is cut. This is cut along this axis. So if it is cut like this, then the magnetic pole strength becomes half. So then the magnetic dipole moment will also become half. Okay, and then the moment of inertia also will change. Moment of inertia will change because the mass will change, right? So the one that does not change, okay, the one which remains unchanged, the intensity of magnetization that will not be changed. Okay, the intensity of magnetization depends only on the material. So the intensity of magnetization does not change. Okay, option C is the correct answer. So next question. Question number 19. A steel wire of length L has a magnetic moment M. It is bent in L shape. The new magnetic moment is. Okay, so let's solve this question. Okay, so steel wire of length L. Okay, so this is given like this. Okay, so there is one steel wire. Okay, this is pole strength M, and here one pole strength M. Okay, so now the magnetic dipole moment will be M into L. Okay, now this is bent. Okay, now this is bent. It is bent like this. So this one is L by 2 and this one is L by 2. Okay, so now what will be this distance? This distance will be how much? Root 2 L by 2 is equal to L by root 2. Okay, so the magnetic dipole moment M dash is equal to, okay, M into L by root 2. Okay, that means ML by root 2, which is equal to M by root 2. Okay, so M by root 2 is the answer for this question. Okay, M by root 2. Okay, so next question. Question number 20. Rate of change of torque with deflection theta is maximum for magnet suspended freely in a uniform magnetic field of induction B when theta is equal to. Okay. So the torque is given as torque is equal to MB, okay, sine, we can write sine phi, where phi is the angle between, okay, phi is the angle between, okay, M and B, okay, M vector and B vector. Okay, okay, so now there is a magnetic field like this. Okay, so there is a magnetic field like this, B vector. Now there is a magnetic dipole. Okay, magnetic dipole. The angle, okay, the angle between the two vectors, this angle is phi. Okay, this angle is theta. Okay, so theta is equal to 90 minus 5. Okay, so they are asking when will the torque will be maximum. Torque will be maximum when phi is equal to, okay, the maximum torque when phi is equal to 90 degree. That means theta is equal to 90 minus phi, which is equal to 90 minus 90 is equal to 0. Okay, so answer for this question is 0. Theta equal to 0, option D. Okay, next one. Question number 21. A steel wire of length L has a magnetic moment M. It is bent into a semicircular arc. The new magnetic moment is. Okay, so what is given in this question? So here it is given that there is one wire. Okay, this has length L. So this has magnetic portion M. So the magnetic portion M is given as, dipole moment M is given as M into L. Okay. Now this is bent into a semicircular arc. Okay, it's bent into semicircular arc. So this angle, how much is given this angle? Okay, semicircular, this is semicircular arc, right? So it will be, okay, so semicircle, so it will be like this. Okay, so semicircle, so it is be like this. Okay, okay, so now the distance between these two will be 2r. Okay, distance between these two, this is 2r. So now arc length is given as, so this arc length L is equal to r into angle is pi. Okay, so r is equal to L by pi. So now you get magnetic dipole moment is equal to pole strength M into 2 L by pi. So this is equal to 2 ml by pi. ml is original magnetic dipole moment, so 2 m by pi. Okay, so 2 m by pi is the correct answer for this question. Okay, so 2 m by pi. Okay, next one. Question number 22. The magnetic induction field strength due to a short bare magnet at a distance 0.20 meter on the equatorial line is 20 into 10 power minus 6 Tesla. The magnetic moment of the bar magnet is. So equatorial line, what is the formula for the magnetic field strength in equatorial line? Is given as mu naught by 4 pi m by r cube. Okay, so the magnetic field is given as 20 in 10 power minus 6. So this is given as 20 into 10 power minus 6. This is equal to, so this is mu naught is 4 pi into 10 power minus 7 divided by 4 pi. So this one gets cancelled into magnetic dipole moment. So magnetic dipole moment is how much? The magnetic induction field strength. Okay, they are asking what is the magnetic dipole moment, right? So that they have given the distance is 0.20 meter. So distance is 0.20. So here you will get 0.2 whole cube. Okay, so you will get m is equal to 20 into 10 power minus 6 into 2 cube into 10 power minus 3. 0.2 cube means 2 cube into 10 power minus 3. Okay, divided by 10 power minus 7. Okay, 10 power minus 7. Okay, so now, so you do this calculation, how much you will get? So you will get 2 into 8 is 16. Okay, so this will be 160 into 10 power minus 9 plus 7 is equal to 160 into 10 power minus 2 is equal to 1.6. Okay, 1.6 is the answer. Okay, 1.6 ampere meter square. 1.6 ampere meter square. This is the magnetic dipole moment. 1.6 ampere meter square. Option C. Okay, next question. A magnet of magnetic moment M is in the form of a quadrant of a circle. If it is straightened, its new magnetic moment will be. Okay, so it is in the quadrant of, it is like quadrant of circle. Okay, this is the distance, so this distance will be, so this is R, this is R, so this will be root 2 R. Okay, now this length L will be equal to, okay, length L is equal to R into pi by 2. Okay, which is equal to, okay, R into pi by 2, which is equal to pi R by 2. Okay, this is length. L is equal to pi R by 2. Okay, so now this is straightened. Okay, this is now what is this magnetic dipole moment? Magnetic dipole moment is equal to M into root 2 R. Okay, this is the magnetic dipole moment, which is equal to M. Okay, let's have like that. Okay, M into root 2 R. Okay, this is equal to root 2 M R. Okay, so now it is straightened. Okay, now it is straightened. So this is a straight line now. Okay, now this length, வந்து என்ன வரும்னா இது வந்து pi r by 2 வரும். Okay, this length வந்து pi r by 2 வரும். Okay, so now this pole strength is M அப்படினா அப்பனா வந்து you will get magnetic dipole moment is equal to M into, okay, pi r by 2. Okay, M into pi r by 2. So from here we can write Mr is equal to M by root 2. Okay, so substitute that here. So you get M by root 2 into pi by 2. Okay, so this will be equal to pi M by 2 root 2. Okay, so answer is option D. Okay, pi M by 2 root 2. Okay, next one, 24. X1 and X2 are the susceptibility of paramagnetic material at temperatures T1 Kelvin and T2 Kelvin respectively. Then it's a very simple question. Okay, so for paramagnetic material, Curie's law, what is Curie's law? Magnetic susceptibility is inversely proportional to temperature. That means Xt is equal to constant. So that means X1 T1 is equal to X2 T2. Okay, so this is the answer for this question. X1 T1 is equal to X2 T2. Option B. Okay, so last one, 25. A short bar magnet of magnetic moment M is equal to 0.32 joule per Tesla is placed in a uniform magnetic field of 0.15 Tesla. If the bar is free to rotate in the plane of the field, what is the potential energy of the magnet in the unstable position? So potential energy is given as U is equal to minus mb cos theta. For unstable position, theta is equal to 180. So we'll get U is equal to minus mb cos 180 is minus 1. So we'll get mb, which is equal to, so now what is the magnetic dipole moment? Magnetic dipole moment is 0.32. So this is 0.32 into magnetic field is given as 0.15. So 0.15. Okay. So do this calculation, then you will get how much? 32 into 15. So you will get 10. Okay. 16, 0. So 2, 3, 0, 8, 4. So you will get 480 into 10 power minus 4. Okay. Which is equal to 0.048. Okay. So it's given like this, 4.8. Okay, 4.8 10 power minus 2. So we can write this like this. Okay, this is nothing but 4.8 into 10 power minus 2 joule. Okay, so this is the answer for this question. So option A, 4.8 into 10 power minus 2 joule. Okay, so we have finished the DPP 5. Okay, so see you in the next session with the DPP 6. Okay, thank you.